Hi and welcome to this math lesson where we are going to look at calculus finding the equation of a tangent line. Now there's a few things I want to mention before we get started, and that is, first of all, the equation of any line is given by y is equal to mx plus c, or I kind of like y is equal to ax plus b. However you cut it, what's important is that this and that is called the parameters. Okay, this is the gradient, it's called the gradient. Okay, and it tells us the direction of the line. Okay, and this is the y-intercept. The y-intercept, and it tells me the position of a line. So a line has both direction and position, and whether we use A and B to fill that position or M and C, that doesn't make a difference. Okay, so that's the first thing I want to tell you. And if we are trying to find the equation of a line, we want to find the parameters. I want to know what must M be for a certain line and what is C, what is the y-intercept. Okay, now generally, this is not always the case. Generally, we will first find M, the gradient. Okay, and that is because we are often given more information about the gradient than we are given about the y-intercept. Let me give you an example. We might have 2 points. If we have 2 points, we use our formula M is the change of y over the change in x, okay? Or they give us another parallel line, okay? In that case, we will use M1 is equal to M2. In other words, I've got another line is given. I know what its gradient is, so the line I'm trying to find is parallel, so it must have the same gradient. Then we have perpendicular. Now perpendicular is that M1 times M2 is equal to -1. If you don't know why, this is not a lesson on that, so I'm not going to go into that now. But yes, I'm either given 2 points, given a line parallel, given a line perpendicular, or I'm giving some other information that relates to the gradient. In this case, that's exactly what I'm looking for. I'm given the information that it's a tangent line. Okay, if I know that a line is a tangent line to a curve, okay, what that means is that at the point where the line touches, where the line touches, the gradients are the same. Okay, so what do I mean? Well, maybe you don't understand what I mean because you don't really understand what we mean when we say a tangent line. So I'm going to take a random just squiggle. Okay, if I were to draw a tangent line at a certain point, I could, for example, draw a tangent line there. Okay, so tangent line is a line that literally just touches in one point, and it is basically, if I had a little man standing on this squiggle at that point, the tangent line is literally the slope he would be standing on. Okay, so if he were to be standing on a skateboard, okay, and we were to extend that skateboard will represent the tangent line. Okay, so in other words, a tangent line is a line that touches a curve. A curve is now obviously not a straight line. A curve in one point, and its gradient is the same at that point as the gradient of the curve. Okay, so for one moment, imagine that this curve is actually a graph, which means that at that point where this tangent line is touching, that's some sort of x value. Okay, some x value. And if I were to substitute this x value into the curve, let's call the curve now f of x. If I were to substitute it in, I would get a y value. Okay, so if I take this x value, let's say that is the value is a, and I were to substitute into the function formula that I must be given the function formula in most of these cases, okay, then I'll get a y value. So if they're asking me to find the gradient when x is equal to whatever, to a curve, whatever that curve is, I'll first be able to find what is this coordinate, the coordinate where they touch. So I will have a point, okay, and I will also have a function value, okay, and if I find the derivative, and this is the next important point I want to highlight, if I find the derivative, and here, if there's one thing you learn in calculus, if there's one thing you should remember for the rest of your life about calculus, even if you never use it again, okay, write it on your grave if you must. The gradient is a formula. I lie. The derivative is a formula for the gradient. In other words, okay, if I take, I've got this is some values with x in it, okay, if I find its derivative, this answer that I get here is a formula for gradient. Now you will notice that at different points on this line, on this curve, the skateboard will have a different slope. Depending on where I am, I will have a different slope. Okay, so obviously for different x values, I will have different gradients because at different points I have a different slope. Okay, so but at this point here, how will I know what is the slope at that point? Well, easy. I take the derivative. That derivative is a formula for the gradient. The derivative will have x in it because if I substitute a value for x, it will tell me what is the gradient at that point. So in other words, if I substitute, again, a is going to be a known value, something like 3. If I substitute that x into the derivative that I found, I will get the slope at that point. Okay. In other words, if I'm trying to find a tangent line, if I'm trying to find a tangent line to a curve, how will I find the gradient? I will find the gradient by taking the point. The gradient will be equal to the derivative. All I need to do is substitute the point where it's tangent, the x value. Okay, so tangent line must cut in one point. I need the x value of that point. If I can substitute the x value of that point into the derivative of the function, I will have my gradient. If this is at all confusing, it's really not. Somehow you need to convince yourself that this is not confusing. It's so simple if you just get this. Okay, so how are we going to find c once we have the gradient? Well, this is the good news. This is what should be on your wife or your husband's grave. Okay, when I have one parameter left to solve. Can you finish the sentence? I substitute a point. Now obviously this point must be on the line. Okay, we must find another point on the line. I wonder, do we have a point somewhere that is on the line? Well, yes, we've got this point. Okay, remember that x is known. We know what the x value is at that point. We don't know necessarily what the y value is, but we can find it by substituting the y value into the f of x, because that y value that's on the f of x is also on the straight line. So this point is on the curve and on the straight line, which means if I can find the point on the curve by substituting x, I will find the y value that's also associated on the line. Okay, and that's basically it. It's really that simple. Okay, let me do one quick example to show you. I'm thinking up one, find tangent line to fx is equal to, let's say, 7x squared minus 3x plus 1 when x is equal to what? Let's say -2. Okay, let's find the tangent line to fx when x is equal to -2. Okay, so we start again just by recognizing, and this is usually where your first mark will go towards as well. Just start with a tangent line to a curve and you already have 1 mark for that. Okay, now I need my gradient. Now there's different ways of finding the gradient. Obviously, when we're working with tangent lines, it might be one of 2 cases. We also use the tangent line when we work with circles and a tangent line to a circle, but then we're not necessarily going to use the derivative. We're going to use the fact that the radius is perpendicular, so then we are using this set here. Okay, but tangent line to a curve, that's not a circle. Okay, you will always use that the gradient is equal to the derivative at the point that was given, -2. So let's find the derivative. The derivative for this function is 14x minus 3. If I substitute -2, I get 14 times -2 minus 3 is -31. That is a very steep skateboard. Okay, that's a gradient, -31. So now I go and I substitute into my formula what I have so far. I've got -31x plus c. Okay, now all I need to do, if I can find a temporary y and x, in other words, a point that I know is on the curve, a y value and an x value, I can just solve c. Easy as that. Well, I have an x value. I know that -2 is on the curve, but what will the y value be associated with it? Okay, in order to find the y value, we can just substitute -2 into the original function. That will give me the point where I want it to be tangent. Okay, I want the tangent line when x is equal to -2. So what is the y value at that point? Well, let's work it out. It's 7. I'm just going to calculate it quickly. 2 squared, -2 squared is 4. Okay, -3 times -2 is +6. Okay, plus 1. So this is a total of 28. Plus 6 is 34. Plus 1 is 35. Okay, I think so. And this is the y value. So I know that the point on the curve is -2, 35. So let's substitute that point in here. Okay, they just temporary replacements for y and x. Okay, so we've got 35 is equal to -31 times -2 plus c. -31 times -2 gives me +62. When I subtract +62 on the other side, I get 62. 35 minus 62 is 27. So it's c is equal to -27, and that's it. Here's my final answer. Y is equal to -31x minus 27, and this is the equation of my tangent line. You can see it's mx plus c. Okay, to this curve which I randomly just thought out when x is equal to -2. So if I draw something like it, there's my curve. It's a very steep parabola actually, very steep parabola wherever it goes, and then at x equal to -2 must be somewhere here, okay, because it's got a negative slope. I've got my tangent line going there, okay, tangent line is going there. That tangent line, when it cuts the x-axis, it cuts it, sorry, the y-axis, it cuts it at -27. Okay, so yeah, that's just basically an idea of the graphical representation of what we just did, but that's not the focus. It's really a very easy topic, and really you can score quite a few marks with this in tests, so make sure that you get it. Okay, so good luck. I hope you enjoy this lesson, and I'll see you in the next one.